So welcome to today's Performance Matters session, where we bring together leaders from across the gaming ecosystem, the creators, the distributors, the network operators, and hardware manufacturers to discuss the key drivers and opportunities and issues that are impacting the industry, especially as gaming becomes more widely adopted thanks to new distribution platforms like cloud gaming, are more graphically rich and immersive thanks to the new innovations in the development technology. Previous sessions have explored the adoption trends and drivers of quality of experience of cloud gaming, and they'll be available to watch on demand from our brand new website, gamebench.net, along with some of our industry research and light paper, which focuses on why performance matters and details our gamer-centric metrics. So today we'll be taking a look at one of the gaming industry's biggest villains, latency. Feel free to post your questions in the Q&A and we'll endeavor to answer them all today. If not, we'll come back to you directly if we have your details. So to kick off, we're thrilled to be joined by some of the gaming ecosystem's innovators to understand how to tackle latency. What is at stake? How are they each addressing this to deliver a smooth gaming experience to the gamer base and customers? So I'll hand over to GameBench co-founder Shri Iyer to kick things off.
Thanks for that warm intro, Jess. I really appreciate it. First of all, really excited to be here. It's the third time we're running a panel and we have a fantastic set of panelists today. So I'm really excited about that. For those who don't know what GameBench does, we provide objective user-perceived performance data across platforms captured using monitoring tools we built ourselves and a rigorous methodology for both lab and field testing. And in doing so, we've been able to help our partners, A, improve the performance health of the products, B, market the USP of the product at launch events and marketing campaigns, and C, through this process, we constantly share our learnings with people we come across, including panels like these. So that brings us to the topic of today's discussion. We've all experienced lag, be it in games or in other interactive media, such as video conferencing. No doubt things have gotten better over the years with high-speed internet, low latency Wi-Fi, but the gamer experience in network-reliant games remains far from ideal. Let's take a closer look at this. Game lags are experienced when there's a delay between the action of the players and the reaction of the game server. At GameBench, we call it input-to-pixel latency. Alongside the internet connection cutting out, they are one of the most frustrating things a gamer will experience. It's annoying because it doesn't matter if you press the button first. If your game lags, the server won't react instantly. So your opponent's faster, a game is faster, they have a much better chance of winning. Such longer than expected latencies result in lag, which in turn will impact outcomes such as gaming KPIs, kill-death ratios, win-loss ratios, where latency matters the most. So how do we tackle lag today? Let's take this to some of the key players in the industry we have on the panel today and find out how they address this problem. So we have Olivier, the CEO of Blacknut, one of the newest clouding platforms today, Luis from Bungie, the creators of Destiny 2. I'm sure there are a bunch of Destiny 2 fans here today. Matthew from EdgeCap and Gino from Nokia with us. To kick this off, I am going to start with Olivier. Olivier, Blacknut is a new kid around the block. Please tell us a bit more about it. And to add to that, are you seeing any early indications of more and more people playing on the cloud? And how much does lag, the topic of today's discussion, impact your users?
Yeah. So thanks a lot, Sri, and for GameBench for this invitation to this panel. I think that's great. So Blacknut is basically a cloud gaming service. I think we are really like Netflix, but for video games. What we do, we actually source, games. We license game from the publisher, from the studio, and then we deliver these games from the cloud using, cloud gaming and streaming technology to basically any connected screens, right? So any screen that can actually play a video can be turned into a gaming console. What is actually differentiating in Blacknut is first that for the subscription per month, you have access to the whole catalog, right? So you don't have to purchase a game in the service. It's all inclusive. So the price point to our customers is between 10 to 15 euro. So for this price tag, you have access to more than 500 games. I think it's one of the largest catalogs these days, PC or console-grade quality games on the cloud. The total value of the catalog, if you had to purchase, each game would be maybe 5K or 6K if you had to purchase all the games, right? So it's good value for the money, right? So that's what we do. Source games, distribute them B2C, give access to all these catalogs. We also distribute the Blacknut cloud gaming service with carriers. Okay, so I think it's a way for us to actually accelerate the distribution of the Blacknut service, and we do this either in Blacknut brand, or we can also do it with a white label customer brand, right? These days we are distributing in more than 40 countries. We have, I think, 10 carriers that are already launched, and we are launching nearly one new carrier per month, right? I think the pace is really accelerating. So as you mentioned, we do see actually more and more customers playing and entering cloud gaming. The angle that we are tackling is a bit different from the big platforms, the big ones, because we are targeting the general public audience, the families, and so on, which we think is very well matched with the current capacity of the networks, in terms of latency, the current capacity of the cloud in terms of GPU performances and cost. So we do see indeed a very good match and an acceleration in the adoption of cloud gaming by the general public.
Great, thanks for that wonderful intro, Olivier. From there, I'm going to move on to Luis here, the creators of Destiny 2, one of our favorite benchmark games. Luis, do you want to just give us, for those who don't know Destiny 2, a bit of an intro, and also from a game developer's perspective, how big is this problem around lag?
Yeah, thank you, Sri, and thank you everybody for the invitation to this great panel. So my name is Luis Villegas. I'm Bungie's Chief Technology Officer. I've been with the company for about 16 years, so we got to see the transition in gaming from Halo to Destiny. And yeah, we're big believers on game cloud streaming being kind of one of the next frontiers. We have this mantra in the company called Play Anywhere. We want to make sure that our games are played from anywhere on any device, and we think that game streaming is going to be one of the biggest accelerators. And then one of the biggest impediments is definitely lag. And lag is difficult to define, and I think this panel is going to be great for us to keep digging deeper. But yes, like if your experience is not great, especially for action games, for games that require kind of that thumb skill, it's going to become a big barrier for adoption, right? If people feel that the experience is very different when they're in front of the couch and console, or when they're trying to use game streaming on a mobile device, I think we're going to have some big challenges. So yes, for us, it's always in online gaming, it's always been a huge deal, lag, and then game streaming adds yet another dimension of lag that we have to think about. So yeah, excited to chat about it.
Great, thanks, Luis. On that note, I'll move on to Matthew here. Matthew is the founder of EdgeGap. Matthew, please do give us an intro. You've built an entire company to address this problem. It would be great to hear about the origins and why we're here.
A little problem. Thanks for inviting me, Sri. And I'm super excited to be talking about lag today. As you said, I'm the founder and also CEO of EdgeGap. So we're a startup based out of Montreal. We've built a platform to help game studios improve their player experience through lower lag. The way we do it is by using a new type of infrastructure called edge computing, which is the notion of deploying smaller data centers instead of having highly centralized one. It's a shift in how studios do things. Typically, they do centralized managements of fleets of game servers. We took an approach of on demand. So each time there's a new match, we looked at the real-time telemetry. We saw, you know what, Lois and Matthew should be playing on a game server located there because it makes a lot of sense at this point in time. That's our biggest differentiators. That's how we know based on numbers that we provide a much better quality of service. In terms of a startup, that's an interesting question because I come from the telecom space. I used to work for and sell to service providers, which are, I think, part of the audience today. And last few years I was at Cisco System. I had seen that edge computing was going to be big. It had a lot of potential. I just came up with this great concept on which we built a patent, which you can see above my head here. And yeah, I decided to, at 40 years old, it was time for me to fly by my own wing, and did the leap. That was in late 2018, and here we are. We have a great success. A lot of studios use our platforms today, and we're making blazing trails, as I'd like to say.
Excellent. Thanks for the lightning introduction, Matthew. And over to Gino. Gino is a first-time, second-time panelist. And Gino, you are in the middle of all of this. Gino's from Nokia. I'll let you introduce yourself, and if you have anything to share, please do, Gino.
Yeah, absolutely. Thank you very much. And indeed, Sri, this is an amazing panel, and I'm very fortunate to be the president of Luis, Mathieu, and Olivier here, and as well as yourself. I lead a team at Nokia called the Innovation Solutions Group, and you can think of us as an R&D SWAT team. We don't report to any business group, business unit, or anything like that. So we're not quite, Google X or Facebook Building 8, but we're pretty proud about the stuff that we work on. 2 years ago, I like to joke that I had a hard time explaining to my kids and my family, my friends, what it is I do for work. So I decided to change that and focus on lag. Now, when I talk to my kids, they know exactly what I'm talking about, or I talk to my friends and family. But all jokes aside, a couple of years ago, I started getting a lot more calls from operators around the world saying, I want to be a better gaming ISP. What can I do? And I think we're going to hear some great things from the other panelists about what we're doing with edge computing and on the gaming platform themselves to be able to provide low latency services. But one of the challenges is that low latency is just one of the dimensions. In my personal opinion, what's even more important than that is consistent latency. So with that, maybe I'll just share 2 quick slides to show the view of it from the Nokia, the telecom vendors of the world. So I'm just going to take 2 seconds here to bring this up. But if we take a very generic cloud gaming latency budget of, let's say, 80 to 100 millisecond, that's a very generous budget if you think about that. That in my book does not necessarily qualify as low latency, so it's a very generous budget. And there's a lot that we can do to accommodate that with edge computing and everything else, and good peering. But when you start looking at it from the telco and the network point of view, there is a big difference between your median latency and your jitter potential. So Ethernet, always good. If you have cable or if you have fiber to the home, or if you're on a 4G or 5G service in the IP transport and peering. And what I'd like to bring attention is, like, if you look at the median latency of all of these, typically, if there's no edge compute, like what EdgeGap provides, then your latency will probably be about 40 to 50 millisecond, because you're not taking advantage of that. But your jitter is very low. That's usually very high-end routers. They do their job good, and everything else. But when you start looking at the 99th percentile of that jitter, you can see that the in-home Wi-Fi or the RAN, or even older generation DOCSIS are the big culprits. I mean, you have orders of magnitude 100 to 1,000-fold X into what that latency is, and those are not things that you can fix. You can't fix in-home latency with edge compute. You can't fix that with netcode. So it really needs a whole ecosystem to be able to do that. And just to show how real this actually is, here's an example of a test that we did using a very popular cloud gaming platform provider, using an FPS game, 60-player battle royale. And this was on a real home, on a real fiber to home network. And when we ran the first test, 10 minutes of gameplay, we had an average latency of a median latency of 62 millisecond. And the service provider and the cloud game provider were really excited. Like, this is amazing. We didn't show them the graph. We just gave them the number. Like, that's half of our budget. Then we showed them the graph and say, yeah, but look at all that 99th percentile latency. Look how much jitter you have. So every time you were spiking over 150 millisecond, you were doing gear shifting to bring down the quality of video to be able to compensate and whatnot. So what my team has been working at Nokia is developing technology with Bell Labs and others in the industry, the IETF and the ITU and ETSI, to develop algorithms and ways to be able to address that. When we turned on some of these innovations, like advanced queuing technology, and we ran the same test back to back on the same service, the same server, same everything, we saw average latency go down to 43 milliseconds, which is really good, but that's not even important. What was more important is we were able to get rid of that 99 percentile latency spikes. We were able to provide a very consistent gaming latency, which really enriches and puts into focus the value of having edge computing and edge caching and all of these good things. So these are kind of like the things that I've been focused on, really working with the service providers. Is you can do everything you want in a network, but you need to clean your house first. So we're helping them with that.
Gino, thanks for the wonderful introduction. I think it really sets the scene well. And what you've really highlighted is that it's not about latency alone. It's not just about lag and latency. It's really about the consistency of your experience, and that, again, the jitter. So I think it's helpful to reset that, because sometimes we simplify this as lag and what's the average latency, but it's not about the average latency, really. It's about the spread, the inconsistency you have, and that's why you get this really annoying experiences. And to really add to that, what we at GameEdge do is we have some tools, and one tool we built was to really see what users are talking about. What are the key complaints around games? So we pulled up this performance profile of a couple of games, and it's not just cloud gaming. We are now talking about multiplayer online games. These are huge titles. So if I were to sort of share my screen here, you will see that. Sorry, where am I doing? Yes, share. If you're able to see my screen. This is, we're pulling up performance reviews from different games, and we can do that using our tools. And if I look up one of the most popular games now, Genshin Impact, you see the largest box over here is lag. And you see into the reviews that people are complaining about, it's too laggy, even on powerful devices. And this is the common theme I see even across other sort of games. And another one is Vainglory. Again, one of the multiplayer games which is available is, I think, the 5v5. And it's been around for a while. And even to this day, you see it's a huge proportion of users who complain about lag. And you can see it has 200 milliseconds of ping, connection issues. The game is serious lagging. And this is something to this day users talk about. Now, what's interesting, going back to your point, Gino, is we did some testing around two platforms on the same game, really on an ISP. And even between platforms, you see the difference in the latency. I mean, this is like really that input to photon latency, where from the time you click on a button to the time you see a response, between Stadia and Luna, you see a huge difference. Stadia clearly is far more optimized, and Luna, as you see, the larger the number, the worse it is for a user. So it's very clear that there is a problem that we see around consistency of latency, and you see the spread of that, but also between platforms, between different devices, there seems to be a problem that users seem to be complaining about. On that note, I'm going to throw this question back at Olivia. You mentioned something about picking the right type of games for a platform. What sort of latencies are you seeing on your platform, Olivia? And do you have a criteria for selecting a certain type of games that is not so sensitive to the kind of inconsistencies that users get annoyed by?
So look, I think cloud gaming is really at its early stage. Even if the technology and the concept has been here for more than probably 20 years. I remember that working in my early days in Orange and Alcatel-Lucent, we were actually virtualizing application on the cloud and streaming them. I think it's kind of recent that the network, the GPU in the cloud, the technology allows actually to develop a proper service, right? But still, as all the panelists mentioned, there are some issues. Okay, there are some issues, and today we focus on latency. There are other issues like the cost of cloud compute and the kind of games you can actually have access and distribute in this kind of catalog. And what we decided indeed in Blacknut is to start with a target population that will actually be already very pleased to discover a catalog of games that is compatible with the current performances of the network today. Okay, and in general, we are quite happy with the latency, which is less than 80 milliseconds. I think we're in the middle of the 100 and the 50 numbers. I think it's something that works reasonably well for us. And again, I want to reinforce the importance of the consistency of latency, which technically is called the jitter, and the variation of latency. For our target audience, which is general public audience, having access to games with a reasonable good latency and the impression that the service is stable, okay, I think is good enough. If you have jitter, so variation of latency, then the service look laggy, a bit clumsy, and this is where actually the perceived quality of the of the game is really seen as degrading, right? So I think we have a very high focus on jitter and stability of latency. And so to start with this vision that yes, I think cloud gaming is just starting, and I think we are targeting a population that will already be pleased to discover, a broad catalog working reasonably well. We indeed first selected games that were not too sensitive to latency, okay, and that were really compatible with this 80 milliseconds, with the capacity to grow as the technology evolves to games that will be even more, demanding in terms of latency. And the technology that we have been mentioning, like for example, edge computing, okay, that actually brings the server closer to the, to the end users, the improvement of the performances of the networks in terms of jitter, so making the latency more stable. There is also, the capacity to get feedback from the network. I think we've been actually testing things here with Nokia to actually, adapt the way the video stream is encoded up front based on the available bandwidth you have. So you can dynamically adapt, your encoding schemes to the network occupancy, definitely improves the latency. And so we see it as, we start with a catalog of games that match this general public audience. And as the technology evolves, as the cloud becomes more on the edge and the performance improve, then we can include games that are even more demanding.
Got it, Olivier. And talking about demanding games, you've done a very smart job of picking the games which lend itself well to what's available today in the network. And I think that's why you see happy users from your side. Throwing that at Luis here, the creators of, high-end FPS games, it's sometimes hard to play such an FPS game on a platform inconsistently. And your game, you build games for all the platforms. What sort of thresholds are you setting around latency for these platforms? And how do you take into account different platforms when you build these games?
So when we start building a game like Destiny, we start thinking about latency in different ways, right? One area is what we call the mission script or the mission logic. And we have components in the backend that handle that part because that part is very, very latency tolerant, right? If you finish a mission and then the door doesn't open for half a second or for a second, that's an acceptable user experience, right? Then the second part is now for the action itself. I think that's where it becomes more challenging, right? Like logic, it can be very mission logic can be very latency tolerant, but the action itself, the simulation itself cannot be, right? Like that's where it becomes very challenging, especially for competitive aspects of the game. Destiny has both competitive and cooperative. So for the cooperation part, we have a higher thresholds, right? So we can have 150 to 300 millisecond latency and still be acceptable. And what you see as a side effect when you start experiencing bad latency or bad jitter is you get see some of the enemies teleporting, but the experience because you're with your teammates is not as bad. Now, if you're doing multiplayer, if you're doing competitive, we believe 150 to 100 milliseconds or below is acceptable. Keep in mind that these numbers are without streaming in mind, right? Streaming adds yet another tax on top of it, so you have to start thinking about how you subtract those numbers to get an acceptable experience. And then when we're building the game, we run a bunch of tests to different simulated network situations to understand if those thresholds are indeed acceptable. Much like Gina mentioned before, the biggest challenge, it wasn't so much on the latency, but on the consistency, right? Because, and not only the consistency, it's also this other part, which is the psychology of the player, right? Like what we experienced after we shipped Destiny, we started getting a lot of reports of lag, and in some cases, we collect enough information to try to build a picture. And sometimes the picture will show us like, hey, last mile networking will be a big part of the issue, right? Like people using Wi-Fi at home instead of having their consoles directly connected, which is what we recommend. that will add some more variability and make the experience not as consistent. But then we found this other part that was very fascinating, which was if you have a bad experience, you tend to blame lag as the reason you had a bad experience. If you lose, you tend to blame lag why that was a bad experience. And then we had to be very careful how to understanding why people like players were experiencing that, and try to correlate that with the data to understand how much was lag, how much was it like any changes that we had to make in our infrastructure of the game, and how much was like kind of the emotional reaction of a game that requires like high level of time scale. So yeah, and then for that, as we start moving forward to streaming, we think that tax that streaming provides for the experience to be consistent, I think has to be 50 milliseconds or less, right? I think that we're not there yet. We understand we're not there yet, but I think that's what makes a game like Destiny playable, highly playable on a streaming platform.
Hey, Shri, may I follow up with a question for Lewis?
Go for
yeah,
it.
so I'm a huge gamer, Lewis, and I stream on Twitch now just for have fun or something to do on the weekends when I have a bourbon to relax after the week. But I've started interacting with a lot of pro players, and it's interesting. You're right. The first thing they'll do is blame lag. And the next thing they'll play, oh, it's the net code. No, they only have a 30 Hz stick or something like that. And I've been banging my head against the wall trying to explain to them, okay, great. Let's say Bungie increases the tick to 120. You do know that you'll be penalized unless you can provide good latency in your home. I mean, there's always a trade-off there. So there's a reason this is done that way, is to provide a more consistent experience. But I guess my question is assuming we can reach that 50 millisecond latency, that would open the door, would it not, to some of these FPS to have a much higher tick rate to provide a more competitive gameplay. But I think I always thought that your netcode wizards have to find the right balance there to be able to provide a good gaming experience, but still satisfying the pro players out there.
Yeah, and that's really challenging because for the pro players, and especially for esports, like every millisecond matters, right? And then for that group, like streaming, like that extra tax they're paying for like 50 to 150 milliseconds could completely change the way you play and could turn a match around. So for that space, I don't know how cloud streaming is going to be able to solve that. I don't know if it's ever going to be a completely viable platform for esports, unless we make a bunch of adjustments on the game side that we have to start thinking about. The other thing that we found is that for most people that are complaining about like the challenges they're having with lag, it's usually sometimes it's not the net code or it's not the servers, it's internet weather, right? Like the internet is always shifting, is always changing. There could be a node app in your network that is saturated. And there's no way for us to be able to detect that or for the player to understand it. So one of the things that we would love for the industry to start shifting is to give more information to players about what's happening. And then we know it's not straightforward. It's really hard. But that makes it easier for people to understand. It's like, oh no, is this part or is internet weather? Is not the net code. It's not the lack of servers. Now there's changes in infrastructure that we keep making, right, to making things better. Like we can move servers closer to the players, right? Like computing on the edge is super exciting for us as we think of different ways we can simulate things closer to where the player is. Again, independent of cloud of game streaming. So I think we're going to see a bunch of advances there that go beyond improving the tick rate. I think improving the tick rate with all the network conditions that we're seeing right now with game streaming won't change the experience in any meaningful way.
That is a fantastic segue to Matthew. One thing we also noticed, Matthew, is when we did our own field testing, we tested the same game, Destiny 2, from different locations. Even on the same platform, we saw variations, inconsistencies, and we always thought that maybe Edge is the answer to this. So on that note, I'll maybe let you sort of comment on how's EdgeGap trying to address this problem.
Yeah, thanks. I'll start first by saying that lag can be many things to different people, and it's being blamed for everything, as Lewis pointed out. In fact, I may or may not have blame lag for my lack of skills against my employees here, because the average age is 25, and I'm going to quote them, I suck at games. But hey, I'm having fun. In terms of lag, so we at EdgeGap focus on network lag, right? So we work with multiplayer titles, and we see cloud gaming, for example, as a device among mobile, PC, consoles, at least from our point of view, from a technical aspect. I'm gonna just show you one slide here. Pop it up. Let me know if you guys can see it. I'm assuming so. Yes, good. All right. So we compare lag sometimes to the commute time, at least from a network point of view. So if lag is the time it takes for you to drive from your house to your office, a lot of the technology that tries to solve lag problems today will try to give you a faster car, create a lane for you on the highway, or build a special highway for you. But really what we do is we take your office and we move it closer to your house in real time, so that you don't have to drive to the highway, right? It's all about picking the right location for each and every match in real time. The way it's done today, as I said earlier, is like the studios will create fleets of game servers in a highly centralized environment. What we do is we take as many locations as possible and we pick the best location. So these are actual examples of a match between two players. This is 1 versus 1. And they were using one of the public cloud based out of Washington, D.C., Washington State. And the average round trip time was 74. By going on our platform, we ended up picking a data center we have access to in Los Angeles, and we went from 74 to 29 milliseconds, right? So the more location you have, the better you can make a decision. Now, this is a 1 versus 1, but if we have 4 versus 4, 5 versus 5, or even like 20 battle royale, it works the same way. We collect the telemetry and we make the best decision, right? Now, to do that, you need a lot of locations. Otherwise, it's just yet another public cloud. And we're growing and growing the amount of locations we have access to. We work with service providers, telcos of this world. They are deploying edge computing, and the more they go toward that direction, the better the service is. So it's a service that improves over time. One thing we do get a lot is, oh, but we may impact the matchmaking time. If we take a slightly popular game called League of Legends, they ended up with a single zone in North America, probably in order to reduce the time it takes for them to match you with someone of your level or your skill set. The problem is they ended up with an average latency of 60 milliseconds in multiplayers, because the servers are highly centralized, probably around Chicago or something. And we've even seen pro players who are used to 10 milliseconds in Europe and Asia, flew in LA to do tournaments and esports competitions, and they were not used to 60 milliseconds. So that was a big bummer for them. And we have 40 regions just in North America today, so we're able to achieve much lower latency across the board. So even if you're LA, as you've seen earlier, we can still reduce the latency. One thing we discovered, and we were not digging into that direction, that's a funny thing. So as we were reducing latency, we created what we called those knobs, allowing for the decision maker to make its decision. And we found out we could tweak what we call fairness, which is really good, because at some point in time, when you make a decision, you're going to try to find, yes, the lowest latency. But as Gino and Lewis pointed out, jitter is really important. We had some pro players comment us on they'd prefer to have 20 milliseconds latency, but no jitter, instead of 10 milliseconds latency in average, but a lot of jitter. So when a studio comes in and create their game profiles in our platform, they can set those knobs based on what they want. Maybe they don't really care about jitter. Maybe they want X, Y, Z. Maybe fairness is really important, as in this case, for example. So we define fairness as the round trip time differences between all of the players within a match. And yeah, the studio gets to select and choose what they would prefer to see in their games, and that's what's going to be applied. And the whole process takes between half a second to 2-3 seconds, so it's totally invisible to the players.
I must admit, Mathieu, I'm a huge fan of the idea of putting the gaming caching directly into the service provider. And I'll tell you an example. I think you're probably going to find this funny, but over the last 2 weeks, we've been working with a Canadian operator on improving gaming latency. And not all of the studios, but many of them use the resources of AWS. Now it's very common to spin up some resources in AWS, run servers or backends and things like that. And in Canada, AWS does have a Canadian zone. It's available in Canada. And a lot of them were using the Canadian AWS zone for operating some of these gaming servers. Come to find out that this particular operator did not have peering in Canada for AWS. So for me in St. John, New Brunswick, Canada, I was playing on a Canadian server. My traffic had to go all through my provider, down to the US, back into Canada, back down in the US, and then back down to me, which defeats the whole purpose. It just made things worse. So having a dedicated network of gaming caching within the service provider network, I think is going to make a huge difference for situations like this, basically.
Mm-hmm. Yeah, we're able to find out issues like you just pointed out by getting the traffic. As we get more and more players through the platform, we're helping studios find out that, hey, you know what? Because there's a system called Matchmaker, and that's going to define whether Gino should be playing against Shri and so on and so forth. It's really game-centric. But we're able to provide feedback to the matchmaker and say, hey, you know what, Bungie, you shouldn't be pooling Shri with Gino because is on this kind of telco's network and he is on this other telco and the peering is really bad. So it makes sense for you, but technically it's going to be a very piss poor experience. So don't do that. So we're providing this kind of feedback to matchmaker at this stage.
Gino is a much better player at the same time, so I would get killed anyway. But on that difference in latency, I think, Lewis, you mentioned something about bad actors, because how do you, from a platform perspective, take care of this? Can you tell a bit more about bad actors? Because that is a side effect of this kind of latency differences, I guess.
Yes, and this is very specific to certain types of games, like games that require connection between all the players, so require a full mesh connectivity. You can also do it with dedicated servers, but it is possible to manipulate your bandwidth, your latencies, like how much data you're transferring, and that could degrade the experience for other people, right? It was very common early on in Destiny for people to figure out ways where they could manipulate the network conditions to starve other players for data, right? So they wouldn't get enough updates about where this player was, but they will get all the updates about everybody else's location, right? So they will be teleporting all over the place, while all the other players will be having a very hard time pinpointing these bad actors. And the bad actors were, in the meantime, like killing everybody else, and their KD ratios were amazing, and that's how they will do very well on the competitive side. So we made sure that we had enough data to understand when this was happening and be able to correlate it across all the peers in the game to understand if it was an issue. So that's the other, that could be another potential area that adds latency, is people trying to manipulate the network to their advantage.
Thanks for that, Luis. On that note, I want to sort of switch gears to actually solution space. So, Gino, I'm going to start with you here, and then move to Olivier after this. Is how's Nokia and your team trying to address this problem, given that you work with operators, ISPs, game devs all across the board? Where are we going with all these problems that we've spoken about?
Yeah, that's a great question, Shri. So as I mentioned earlier, there isn't a week that goes by that I don't get a call from a provider saying we need to be better at gaming. This is a critical part of our business now. So we've been focusing really on where we can have the biggest bang for the buck, which is addressing those consistent latency hotspots in the home. Wi-Fi. What can we do about that? Developing new queuing algorithms, advanced queuing algorithms, so that service provider CPE is not in the same commercial space as a high-end $600 gaming router, but we need to provide the same level of performance, which requires more than just brute force. So we have amazingly brilliant people at Bell Labs, for example, 9 Nobel Prize winners over the years that come out of there. And they'll come say, hey, Gino, we got a great idea. We built this gaming algorithm. And the first thing I'll say, awesome. How's that going to help my kill death ratio? And they just look at me and they blink in their eyes. I said, okay, fine. How's that going to help my FPS? And again, So we go through the trouble of doing a lot of the real world testing, understanding how these algorithms get applied to real things like gaming, where you have TCP control channel and UDP packets that get sent for, on a certain Hertz rate and all that stuff. So we've been developing a lot of this technology, but even more so, we understand that this isn't a Nokia thing. We have to develop things that can be adopted across the whole industry. A great example is, everybody's heard about low latency DOCSIS. It's great technology that's about to become available in all of North America. But low latency DOCSIS is actually built on an IETF standard called L4S, which was developed by Nokia. So we submitted this to the IETF, we built it. Cable Labs adopted it in low latency DOCSIS, and we're implementing that in our devices. So for me, in a session like this is exciting because having access to Louis and Mathieu and Olivier, and I said, you know what, if we can work with you guys in adopting things like L4S, we can dramatically address the consistency of the latency issues, because we can make the equipment respect that in the home, in the network, routers, switches, peering points. So there's a lot of different things that we're doing, but again, we're putting the gamer hat on. Like when I said I was streaming on Twitch, I'm not kidding. I do this because I see what's happening, and when there is lag, I go and find out where it's coming from. Yeah, you know what? My kid was running his microwave. That impacted my Wi-Fi performance. Now, I can't go and blame it on my provider anymore. So we do things in two ways. What can we do on our devices, and what can we do on the overall technology industry to help everybody become better?
Thanks, Gino. And on that note, I'm going to switch the question to Olivier. Based on what we heard from Luis in terms of ideally having a global budget of 50 milliseconds. And I think I'm going to publish that because that actually becomes an aspiration for all of us. And if that happens, you can play Destiny 2 from anywhere, even if I'm in Antarctica. How does that sound to you, Olivier? I mean, does it make sense to have, let's say, a standard of some sort that cloud platform vendors have to conform to? Would that be 50 milliseconds, 80, 100? And you've taken a slightly different approach saying, let's talk about games instead of the latency. So how would you welcome a target of that sort that people have to conform to?
Right. So first, I want to stress, as Gino or Luis mentioned, and I think that that's very important, that the latency is multifactorial, right? I think it comes from different sources. And I think the diagram that Gino mentioned at the beginning was really, very interesting, because you see that there is some bucket of improvement, unitary buckets of improvement, both on the latency and the jitter. And I think all the actors can work on it independently, right? And there is some quick wins here, right? You can improve, for example, the peering, as I think Matthew mentioned, right? I think if your traffic goes all around the world, then of course, even if you have closed server, it won't work. You can improve basically the network access in the home. You can improve the latency of the device, of the gamepads and all these kind of things. And so I think there is some quick wins to improve all this. And indeed, the ultimate thing would be to have all the actors of the industry working together to actually reach a certain level of quality and improve, the whole experience together. And we are seeing this happening, right? When Matthew mentioned that, okay, we can give some hints to the publisher, to the person that operates the service on how we should do this, that's great. I think we get similar information from Nokia on the, on the servers, on the feedback from the network, on how the networks degrades or improve over time. So I think that we can use it as well. Game publisher, so I think can also give us hints, on how the games and what are the requirements in terms of latency. And then we can, mention to our customers, what, your current network or latency jitter, package is not great enough. So I think you should not play these games. When it comes to standards, if you put here some standards, okay, this should be, the gold numbers that you need to have. Look, I tend to believe that this will not really help, right? If you look at the way the video industry evolved, please remember the kind of crappy video we used to look at on the internet and be very happy to actually watch these videos, okay? And say, yeah, that's great, I can watch this video, And I was one of the earlier, person working on coding, technology and having, video streaming on very, very, very low leads, right? So if you impose some standard, then I think you're basically driving away from, I think, also the root of the internet to do best effort to provide the service that, that's what you can get, if you enjoy it, great. If you don't, then you have to wait maybe more, or you have maybe to pay higher, or these kind of things. So that's the way I would see it. Okay, I think a standard like imposing, the industry to respect it, I think won't help. Having some kind of target goals. Okay, say, look, if you have this, then likely you are going to have a great experience. Yes, but I think we should really leave some space for innovation, evolution. Also, one thing that is also very clear on our side is that it also depends on the gamer itself, right? Something that will look perfectly acceptable for, I would say, a casual gamer or general public gamer, and he will play maybe Destiny 2 with some lag, but actually he will like the experience because he will discover a game, and that's good for him, right? But if you provide the same experience for an esports gamer, then we say, look, I cannot play here, right? It's not my stuff. So I think we need to accommodate basically the different typology of gamers that we have as well.
I think that's a great answer, Olivier. I think there's so many variables over here to take into account instead of blaming everything on lag. That's the type of game, that's even the mechanics inside a game, at Lewis's pointing out, when you open and shut a door, when you crouch, when you run, when you shoot, everything has different budgets, different latency targets. So it's really so subjective. And also at the end of the day, user, you're trying to move a lot of people to the cloud, and clearly BlackNet, you're having success bringing families into the platforms, and different games are going to have different budgets from that perspective. So it's interesting to see how this area evolves and how do we address this. On that note, I think it'd be great to maybe have some kind of benchmarking information. For instance, look at this platform that achieved this on this network. So I think if we have examples that we can aspire to, and I think that actually might be useful, because that way we somebody else has done it, which means you could also do it. And I think that's something that we as GameBench are trying to share, saying, what do we see on Luna? What do we see on Stadia? What do we see on GeForce now? What do we see on 5G, 4G? So that way, I think real world data could help all of us sort of aspire to be the best in class in a way, if that's relevant. If my grandma's playing a cloud game on BlackNet, then maybe she's not looking to shoot people. I think maybe she's just playing a card game. So that's an angle. One thing we did mention was the question that comes up to us again and again is 5G. And 5G and cloud gaming, 5G and network-centric gaming. Are people going to move from the home and play these games anywhere, everywhere, sort of thing? And this, I think, goes to all of you. Where do you see 5G taking us with respect to cloud and network-centric gaming? Will we be able to hit those consistency numbers in any time in the near future?
Well, that's a good one. Maybe I'll take the first stab at it, Sri. So the first thing to understand is, 5G, there's a lot of marketing hype behind it. There is such a thing as ultra reliable, low latency 5G, but that's really meant for the industrial space. The tax that you have to pay on it, the amount of bandwidth that you lose by being able to offer that is pretty much astronomical. So when we were talking about regular 5G, the benefit is the high bandwidth that you can achieve, especially with millimeter wave, which is very conducive to cloud gaming. So I think 5G will provide a much better platform than LTE itself, but it will be because of the throughput. Latency, there are things that can be done. For example, I mentioned L4S, which Cable Labs has adopted, but L4S is also something that's being pushed in O-RAN for 5G deployments and the 3GPP as well. So once we have a mechanism like that, where the network understands the applications and understands congestion and lets the applications deal with it, I think 5G will be very conducive to that. So today we'll address things in the short term with the gobs of bandwidth required for cloud gaming. And I think there's still some things that we need to do in the future to be able to address the consistency of the latency, because 5G in and of itself doesn't really fixes that out of the box.
Maybe I can take our take on it, from a BlackNet perspective, because as you mentioned, yes, there is a bit of marketing on 5G, and actually, when a carrier launches his 5G networks, you also want to launch it with a very compelling service, something sexy, something new. And I think bandwidth's great, and more Netflix, more Spotify, and these kind of things. But that, I think, is not very sellable. And for the general public, with gaming, becoming massive, in terms of entertainment. Everybody's playing, even my mother-in-law is playing, right? So I think it's really crazy how gaming has been becoming popular, right? I think 5G actually enables cloud gaming in a very nice way. From a technical perspective, okay, because of the latency, because of the bandwidth, because then you can actually bring your games everywhere. And I think the first stage is actually to really transform your mobile devices into a gaming console. Okay, so we don't believe so much that having mobile games on mobile is really nice for cloud gaming, not really relevant. But actually bringing great games and PC great games, console great games on mobile, that definitely makes sense. And connecting this with a gamepad actually make it a very nice, a product. Basically, it's transforming your mobile devices into a Nintendo Switch console, right? And that I think is the first stage. And the later stage is actually having this console being able to be transportable, to bring it everywhere, to connect it, for example, to a TV screen, right? So you go to a friend, you've got your 5G mobile devices, you connect it to the big screen, and then here you go. You have your PC games running on a big screen with the 5G devices. So that's a kind of evolution that we see. So yeah, it's a great enabler. We are launching really one of two carriers we are launching these days. It's a 5G launch, and it can be either for launching 5G or an extension of their current services that they have, for example, on broadband, on set-top boxes, that is being enabled as well on mobile.
Great. Olivier, I think we're reaching the last 10 minutes of this panel. I have one question for all of you. The 5G answer was fantastic, Olivier. In fact, I'm going to expect my 5G provider to ensure that I can play Destiny 2 and not lose. And I think that's when I know it's working. One question that is actually quite recurrent, and I think for all of you, please take a second to answer this, is where do you envision that we can see the biggest improvements in the next few years around network-centric games? What do you think is going to be the future? What's going to drive this, and what can we expect as users in the next few years?
Yeah, I'll take this one, at least from my very, very humble perspective, as someone who comes from the telco. So I see that the infrastructure is connecting more and more with the application layer, right? An example that comes to mind is, and we've shown that at Mobile World Congress in 2019, where if we detect that for a given player, the quality of the connection starts to degrade for some reason, we're poking the core network and say, hey, you know what? Shree's connection is bad, so increase the QoS. Or we have this group of people playing together. Please create what they call a slice or private network, quote unquote. So the work or the synergy between the infrastructure, everything that used to be a black box hidden stuff, and the end users is getting closer and closer. And Louis talked about providing feedback to users. It's something that we've also been working on. I've seen it done in Apex a few weeks ago. They've announced it, where at the the corner of the screen, you get the amount of jitter, the drop, and like not just purely latency. So providing feedback is really, really important. And we're at the stage where we're helping studios to let the player know that, hey, you know what, you have a problem, and we're trying to do our best here. Don't go online complain about the game, because your network is the problem, or your mobile or your PC or whatever, right? You're in the train, you keep hopping from antenna to antenna. Don't expect the same thing as in your living room, dude. So yeah, this synergy is going to be key in the next few years, I think.
Great. Who wants to go next?
Well,
Louis?
it's funny that you mentioned that, Mathieu, because when we do the real world testing that I was talking about, we actually do try and rely on games that expose that level of data. And I'm just going to pull this out really quickly. Here's an example. So you mentioned Apex that exposes some of the debug level information. And when we want to show the real world results of some of those queuing algorithms we're developing, you'll see at the top, when we played a game in a real home on Wi-Fi 5 gigahertz, you'll see round trip delay of 149 milliseconds, jitter of 9, and whatnot. And when we ran the same tests with this technology enabled, we saw a round trip delay, you get down from 150 to 56, jitter down to sub 2 millisecond, and the quality increased dramatically. So I love the idea of what you said, that the application network are becoming much more in tune, much more to a point where I think the two will be programmable. The application will be able to give feedback to the network and vice versa on how things should work. So, but you're absolutely right. That's something that we pay a lot of attention to directly into the games as well.
Yeah, so we do see this collaboration part really as a short next future. Okay, so having APIs, from the networks, having APIs from the games, and we as a platform, allowing to optimize everything. Ultimately, if we are a bit more forward-looking, likely the innovation will come from the game. At the end, everything is about content, and I'm sure Luis may have some ideas on it, but the idea will be indeed to have what we call at .NET cloud native games, right? So games that have been built, from everything that the cloud provides and that are optimized with all the nice APIs we got from the network, that nice location and all this kind of optimization. So that I think would be the evolution of the industry here in this space using cloud technology.
Thanks, Olivier. Any words, Luis?
Yes. I think there's a couple of things. I think the first one is, huge improvements on the infrastructure and how the infrastructure connects with the game. Like everything that Matthew mentioned, for example, resonates strongly. And some of that we had to build like ourselves in the past. We will love the infrastructure to take care of it. I'll give you an example. Like Destiny requires like a full mesh connectivity. And when two players were having issues connecting with each other because of NAT restrictions or anything else, then we will bounce the traffic of a third NAT relay that will be more reliable or make sure that those two peers will talk to each other. Like we will love as game developers never to have to think about those type of problems directly, and instead try to integrate better with infrastructure in different ways and understand how to do that more effectively. So I think that's on the latency side. A lot of the edge infrastructure changes I think are going to bring a lot of improvements for gamers. But I think there's another part about cloud native gaming that is going to keep evolving. Like so far we have all these amazing like services or platforms for cloud native gaming or cloud streaming. But I think we're going to start moving hopefully to something more like white label streaming, where it's streaming as a service, where I can say like, hey, I build my game only once, right? I put it on this service, and from the user perspective, it's completely invisible, right? Like they double click on the Destiny icon, or they launch it on any console or any device, and they don't even know that the game is being streamed. Like everything is invisible to them. And then for us as game developers, we're using that service, that white label streaming that we call, as a way to deliver that experience to all our gamers. So I think we're going to have the ecosystem of subscriptions, which is going to be the platform service that a lot of different companies are trying to pursue. But then we're going to have also that white label streaming for game developers to also try to provide that invisible experience if we wanted to.
Luis, thank you so much. And we have about a couple of minutes left. So I think it's fair to say we can start wrapping up. And I think first, only one thing I want to say is first, a huge thank you to all of you. It's very clear that we are sort of walking down a progressive path here. I think we all understand what's the problem we're trying to address, and we have some solutions, but all this needs to come together with some common terminologies, common language, and also being able to present data back. I think data is the king here. If users have data, if we have data, if infrastructure providers have data, we can actually act on the data. So I think it's important to state that if we are to work together, we have to sort of bring together data that we can act on to see where we're headed and how much improvement we can actually deliver. Jess, I'm going to hand this over to you because we do have an interesting sort of survey question to ask, and we can sort of also reveal the results right away. So Jess, back to you.
Sure. So we are looking at a little bit of audience interaction now as we wrap up. So I'm going to launch a poll, and it would be great to have everyone's input. So the question we're asking our audience is, having heard the benefits of low latency networks, how much would you pay your ISP or mobile network provider for guaranteed, consistent, ultra low latency gaming and video conferencing? So you can see that there's 3 tiers. And We're just receiving your votes now. And I'm going to close the poll in 5 seconds. And closing now, so end polling, and here are the results. So you can see that there is a nominal price that people will pay for that consistent, guaranteed experience.
Wow, and interestingly, 34% say it should be free. So, well, that is a good percentage of those to where it should really become standardized. Very, very interesting, Jess. Thanks for running the poll. Great. So this brings us to the end of the panel. We will definitely share some of the collateral that we had from this panel with the audience. There will be more of these, and there'll be more sort of topics around gaming in general and how we sort of work together as an ecosystem. But I would like to thank you all for your time today, especially the panelists for taking the effort to put things together, to present what you've done internally, and we hope to have you again back in a panel in the future. So thank you so much. Thank you, audience. Thank you for showing your support.